Finally, we have people workflows that we have to keep in mind. As I said at the very beginning of the presentation, we have a product designer that is changing the products, creating these engineering change orders or engineering change requests. Those get routed to typically someone in manufacturing, called often a manufacturing change coordinator, who is routing these process change requests to particular engineers. Now, those engineers may be selected based on the area of the facility that they work in, or they may be simply selected based on their discipline or domain, or perhaps availability. But regardless, the workflow here from a staffing perspective, an engineering perspective, is that we are assigning the change of the part to an engineer who goes through this entire process planning exercise that I talked about, from the time studies, to the work instructions, the line balancing, even the workplace design and in-plant logistics. Once that work has been completed, it's checked back in and then distributed based on what's called an effectivity date. That is a date at which this process change will now be active on the floor. That, of course, then will be the release date that a person on the floor using the shop floor work instructions, using the ERP system, or using the handheld barcode devices for part logistics will actually see that change, and that change will become now effective on the floor. So the final parting word here is that process engineering today is largely broken. The means in which we actually take a change to the product and get that change reflected on the shop floor is very time consuming, very inefficient, and there's a wide range in the overall quality of that design. More importantly, there isn't a good process today at work which ensures that a line or a production system or department as a whole has the most efficient, the most productive design, because it's a bit of a hodgepodge of work performed at different times. So oftentimes the process routing doesn't match the bill of materials, or the tool list doesn't match the requirements, or the parts on the station aren't accurate. If we can focus on that and we can fix that with the same engineers, we can perform a considerably better job in process engineering. In other words, we can create a much more efficient production facility, and we can do so in the same time, or maybe even less time here, and get those new product launches done sooner and into production and out to the customers sooner. And that's really the whole name of the game of lean process engineering. Hopefully this has been beneficial to everyone, and certainly if there are any other questions, I'd be happy to address those.